Good morning, one and all. Today we discuss about forces between the multiple charges or principle of the superposition of the forces. Okay, here going to this class we will discuss them in the previous class. That is Coulomb's law. We will discuss in the previous class. That is Coulomb's law. Coulomb's law. That is, the force in between the two charges is proportional to the product of the two charges. That is, F is proportional to the Q1 and Q2. Here one is Q1 charge. Here Q2 charge is replaced. In between them, the distance is R. Okay, the force is developed in between the charges, two charges. That is, the force is proportional to the product of the two charges. Okay, and also the force is inversely proportional to the square of the distance between the two charges. Okay, from this equation we get F is proportional to the Q1 Q2 by R square. Okay, we want to remove the proportional. That is, F is equal to K constant into Q1 Q2 by R square. Okay, this is a general formula for Coulomb's law. Okay, if medium is there, if force in a medium, that is, you can write the F is equal to 1 by 4 pi epsilon naught into Q1 Q2 by R square. It is in a medium. Okay, sorry, is in a suppose it is a force. This is K is equal to, here epsilon is the permittivity in a free space. Okay, suppose if force in a medium, it is in a free space, both will be in the same. Okay, force in a medium is equal to K, that is here 1 by 4 pi epsilon is equal to Q1 Q2 by R square. Here K is equal to constant, that is 1 by 4 pi epsilon naught from this equation. Okay, this equation is in the free space. The K is equal to 1 by 4 pi epsilon naught. That is, epsilon naught value, pi value, 4 value, we get 9 into 10 to the power of 9 Newton meter square by Coulomb square. It is a constant. Okay, it is a force in a medium. It is a epsilon. Epsilon is the permittivity of a given medium. Okay, suppose the force at Q1, that is F12, that is force on a first charge Q1, it is due to and second charge, that is F12. Okay, F12. Okay, here the force, that is F21, that is force on a second charge due to first charge Q1. Okay, that is, both will be in a same magnitude, but they having opposite direction. That is, F12 is equal to F21 magnitude, but opposite direction. It can be obey the third law of Newton's third law. To obey the Newton's third law. Okay, they having some applications in the Coulomb's law. Okay, see here, already some problems are doing yesterday. If K is equal to 5, what is the epsilon R? Okay, you know relation, that is F force by in a free space, force in a medium is equal to epsilon by epsilon naught is equal to epsilon R is equal to K. This is the relation, okay, in between the two forces, force in a free space, force in a medium. It is a permittivity in medium permittivity in free space. The ratio is the relative permittivity of the given medium. Okay, this is K is the dielectric constant of given medium. Okay, here this is the problems are coming in this relation. Okay. Okay. Suppose if the forces in between the one charge having positive charge, another one having minus charge, the force resultant force is F12 direction is like this, minus to here this direction. F21 direction is this direction. Suppose if both here Q1 having negative, Q2 having positive, okay, F21 direction is same like this. Okay, direction is like this. Suppose if having both is negative, okay, here second, that is charge on second. Okay, F21 means the force on a second charge due to first one. That's why the force is this repulsion force. Sorry, attraction force. Attraction force means here positive, here negative. Here also negative and positive. That is attraction force. Here both will be repulsion force. Sorry. Okay, both will be in the like charges. Okay, positive or negative. Here, okay, here both will be the positive, here negative. That is F12 charges in the F1 first due to the first charge force on a first charge due to second, that is direction is like this. It is right to left. Here also same, right to left. Both are having same charges. In this case, different charges, unlike charges having F2, that is second force due to like this. It is first force, it is second force. Okay, and also the net force. Suppose they having in the same direction, the net force is F1 is equal to F12. That is a result force of the two charge carriers. Okay, first charge having F1, second charge having F2. The net force is like this. Suppose if they having opposite direction, the net resultant force is equal to F1 minus F2. That is having resultant opposite direction. Okay, suppose if they having some the forces having two difference between the two forces having some angle, the net force is equal to F1 square plus F2 square plus 2F1 F2 cos theta. Problems are coming in this one. Again, these are the applications of the Coulomb's law. Okay, now we will discuss about forces in between the multiple charges or principle of superposition of forces. Okay, in the previous Coulomb's law only deals with the only two forces, two charges is there. We get the relation between the charges distance, that is the Coulomb's law. If force charges is more than two charges, we get the forces. What is the multiple of forces in between the multiple of charges? That is according to superposition of principle. You know, relation, that is a displacement of wave, that is y is equal to y1 plus y2 plus y3. That is the having addition of the displacement. Here the forces is multiple of adding the number of forces due to charges. Now we will discuss. Okay, here a system having suppose three charges. Here Q1 charges, here there is Q1 charges, here Q2 charges, here Q3 charges, here Q4 charges is there. Okay, here this Q1, Q2, Q3, 4 charges is there. They having the net force on a Q1. What is the resultant force on a Q1 F1? Okay, that is here that is the distance between the second charge to second one, that is R12 or R21. That is the distance between the two charges. Second charge to first charge, it is R21. This force is repulsion force. It is F12. F12 direction is repulsion force, like this. Suppose if Q3 charges, this distance is R13. Okay, the distance between the Q1 to Q3, that is R. The force is, this is the resultant force from Q3 to Q1, that is F13 force. Okay, next, if the charge from the fourth charge, the resultant the force due to on a fourth charge, that is F14. Okay, there is a first charge due to second charge, due to third charge, due to fourth charge, that is F12, F13, F14. Suppose they having, the system having number of, suppose Qn, suppose here Qn, that is they having on a first charge Q1, that is force is F1n. Okay, there is the forces due to. Okay, suppose we can write down in the first equation, you know, general formula, Coulomb's law, F is equal to K Q1 Q2 by R square. Okay, this is a general formula. Okay, suppose we can write down from Q to Q1, that is F12 is equal to, okay, there is a vector in the form of vector, that is K Q1 Q2 by R. R is the distance, R12 square. Okay, in the form of direction or magnitude, that is R12 cap. Okay, this is a force due to second charge to first charge. Okay, that is force on a first charge due to second charge, that is K Q1 Q2 by R1 square. Okay, that is direction, that is in the form of vector form R12. Okay, that is equation number 1. Suppose if force on a third charge, on a first charge due to third charge, that is F13. F13 is equal to K Q1 Q3 by R13 square. Okay, direction or magnitude, that is cap R13. That is equation number 3. Equation number 2. So we can write down the next force on a Q1 due to fourth charge, that is F14 is equal to K Q1 Q4 by R14 square. Okay, the direction or magnitude, that is R14 cap. Okay, that is equation number 3. Okay, now we can write down up to n, the force is equal to 1n. Okay, the force due to on a first charge due to n charge due to n charge on a first charge, that is F1n. F1n is equal to K Q1 Qn by R1n. The distance here R1n. Okay, R1n square into, okay, that is the magnitude R cap 1n cap. Okay, that is equation number 4. Okay, according to superposition of principle, that is F is equal to F1 F2 plus F3 F4, like this up to Fn. That is the net force on a Q1 charge, that is F1. that is net force on a q1, that is F1, that is equal to F1 is equal to here F12, sorry, F12 plus F13, F14, F15, F16 up to F19. Okay, here 12, here F12, F13, like this. Okay, it is mistake. In net force, that is according to superposition principle. This is net force due to on a q1 charge, that is F1. F1 is equal to first charge F12, F13, F14 up to 1n, Okay, this is a net force on a first charge. Okay, we can adding this all forces like this from equation number 1 and 2 and 3, adding the all forces, that is F1 is equal to equation number 1 like this is K Q1 K Q1 Q2 by R12 square R12 cap. Next F3, that is F13, that is K Q1 Q3 by R13 square cap R13 cap plus K Q1 Q4 by R14 square into R14 cap up to K Q1 Qn by R1n square into R1n cap. Okay, this is in the form of vector form. Okay, that is the total force on a F1, the total force. Okay, here see here only two charges, you can taking only two charges, that is Q1 Q2 Q3, only three charges. Okay, the Q2 charges on a Q1, that is force is like here. Okay, and Q2, that is F13 here F12. Okay, this force. Okay, in using number of charges like this, you can taking number of charges up to n, we can we get the number of forces due to first charge. Okay, that is F1. The F1 is equal to sum of the individual forces on a charges. Suppose we can in the two charges, we can adding the only 2, the total force on a F1 on Q1 due to two charges only. Here only two charges. Here okay, taking up to n, the we can take adding the number of charges F2n. Okay, here from this equation we can write down the here K Q1 K Q1, here K Q1 all having K Q1 is equal to common, that is F1 is equal to K Q1 by K Q1 into here Q2, next here Q2 by R12 square into R12 cap plus Q3 by R13 square R13 cap. Okay, next here Q1 is common, next Q4 by R14 square into R14 cap up to Qn by R1n square into R1n cap. Okay, here KQ1 is common, KQ1 and is always in common taking. Okay, from this equation you can write down KQ1 by KQ1 into summation of n is equal to n is equal to sorry, here I is equal to, okay, from this equation we can write down, simplify last one, that is k q1 by summation I is equal to 2 to here starting here q2 starting here I is equal to q2 to n, q2 to n, here up to n, that is q to n, here q1, it is q2 I is equal to taking 2 by r1i into r1i cap. Okay, this is the net force on a first charge q2, the net force on a charge q1, having number of charge carriers, the net force on a first charge. Suppose you can simplify here r, it can be written as k is equal to, in the form of q1 by 4 pi epsilon value into summation of I is equal to 2 to n is qi by r 1i into r 1i cap, here square. Okay, that is f1. Okay, that is a force, it is in the form of k, the k is equal to 1 by 4 pi epsilon naught. Okay, here taking q is equal, I is equal to 2 means here I can taking I is equal to 2, that is q2 by r12 square r cap. Next to I is equal to 3, this one 4, this one like this. Okay, simplify this summation, this can be written as in the form of, so this means the resultant force on a first charge q1, that is force f1 due to all charges q2, q3, q4, q5 up to n charges, that is the summation of the individual of the all forces, that is superimposition of the forces. This is the consequence of the Coulomb's law and superposition of the principle, because superposition principle is the net force is equal to sum of the individual forces, the net force on a q1 is equal to due to all forces, that is the superposition of the principle on charges. Thank you, one and all.